I'm a software engineer, and in this video, I will be breaking down a full stack application I made through a presentation. The project I made was a habit tracker for developers, and you can find the code in the description. Starting off here, we have the roadmap. This is our roadmap. We're going to go through views and hooks, state and endpoints, and lastly, controllers and services. So the working project summary. We go from views, so we have a home view, activities view, and sign up, to hooks, which would display our information and handle all the logic when you click buttons, things like that. Which hooks use the state to display all the stuff that we need. But first, we need to grab that by sending requests to the backend to hit our databases. So we do that through stores. Our stores will hit our backend endpoints. In our backend endpoints, we'll first go through our middlewares that we have set up, and then go to our controller layer and call the functions there, to then our service layer, here our service layer, and the response. So in this case, if it was selecting the activity name and we return the activity totals, we would return that response to the controller layer, which would then return the response all the way up to the store level, which would then return it and set it to state in our functionality. And from our state, finally get to display to our wonderful users. Each page in the project was a view. So here is the actual project, and this is my home view. This is the home page. And here is the main meat and potatoes, which is the activities view. So here you can log an activity, your heat map, which would add up all your activities throughout the days, and depending on how many activities you have for that day, it'll change the color. And we also had a leaderboard where you could rank against the other users that were on the website. And lastly, we have the sign up view. Now each section in a view is a component. So for example, here in our home view, we have the header component and the home component. In our activity view, we have our activity logger, activity totals, heat map component, and leaderboard component. Same goes with our sign up component. Views have components inside of them. Number 3, views are just functions. So this is how you would make a view. You would start with the function. This is home. This is an expression, and export it. Same goes for activities. This is function, actual function syntax here, and we export it. Same goes with sign up, and same goes if we have or are adding a user settings. Now, number 4, I use components as functions inside of views. So here we have the home view function, and inside of this, we're returning and using other little components, which are also just functions. Same goes for here in our activity view. We use handle GitHub login, activity logger, activity totals, heat map, and leaderboard components inside of our view function. Here the same goes with sign up. We have this function, and instead of this we use components. Now number 5, demonstrating the same concepts on more examples. So here if I go to Nike's homepage, this is how I would break it up into functions and components. So here I have Nike's homepage view, the header, the store nav bar, switch places, switch pages, totals, filters, its side filters, and lastly, the Nike clothing results. That's how I would break this up into components. Now here I have the school about page, and this is my school about page. Logged in nav bar at the top, community hero banner, leaderboard component, and about description. Also, if you're curious about this offer, be sure to check out school.com/techascend. Now number 7, components use JSX to structure and style. So all components are also just functions, and they use HTML and CSS to visually change, right? So here we have our logo, which is used in the home view, and inside we have CSS alongside HTML. And here you could swap this out with a framework like Tailwind, but this project is really simple, so I decided to use plain old CSS. Okay, same goes here with the leaderboard. This is how I colored it in. I have CSS, I'm using CSS here with HTML with JavaScript, embedded JavaScript. Number 8, views and components make up my routes. So this is the initialization of the app, which would be app.tsx on our front end repository. And in our front end repository, we set up this router provider in the app, and this would be all of our routes that the users can hit. Now you can nest them and things like that, but this is how mine is set up. I have 4 routes, which is sign up, home, login, activities, and then one for any route that's hit that is not the top 4. And here, as you can see, I'm passing in guarded route to the element property in route. This is so that I can authorize routes depending on what authentication the user has. So sign up, home, login, and all other routes which hit home are public. Is public. You see this is public. That means that if you're not authenticated, you could still hit this route. However, if it's login required, you do need to be authenticated. Now we're going on to hooks. Components use hooks to execute all business logic. So here I have activity totals, and we use this hook called use activity totals. Use activity totals is a facade hook. What a facade hook is, hides all the logic that we have for this particular view. So since this is activity totals, we name it use activity totals, and this would hold all the logic for that page. Our second example here would be in heat map. We have this use heat map facade hook where it would hold all of the functions and constants or manipulating state for our view, so that our view is only to JSX. The second part of hooks is facade hooks use stores to send requests to the backend. So this is more or less the hook lifecycle in my application, where I have a hook level that goes into a store level that goes to the endpoint level, which would then go to the backend. So our hook level here, this is a function inside of one of our facade hooks. And here we call activities store and a function inside of activity store, and we set the response to that state. So what is that? What's really happening? So if we go inside of the store, we see we have a couple functions here too. These functions call endpoints, and they return the response of these endpoints. Here's a second example. We have fetch activity totals that calls a store, which is just functions that call the endpoint to the backend. Now here in the store level, I can set state. Now, we'll get into state in just a little bit. We're now officially done with number one though, which is views and hooks. So now you have a glimpse and understanding of my full stack applications UI and the hooks behind it. Next up is state and endpoints. State is used to transfer, save, and display data. Here I set the activity date state with the response. As I mentioned earlier, we call this endpoint and then we take the response, return it, and we set it into state. This is what we eventually display here. On the heat map component, we would map this result into a heat map component, and that's what gets displayed. Here's another example. I call the endpoint and I set the activity totals into state, which then gets displayed on our activities view. Now, creating state can be as easy as initializing a constant. So here I'm initializing activity totals, and I have a second function here that's set activity totals that I can call to change the value of this activity totals. Now, next up is endpoints, because we are now at the level where we're hitting endpoints. Our stores are calling endpoints in our backend. The backend server initializes our connection with database, Redis, and the router. So we don't really need to go into the nitty-gritty of how the application starts up and boots up on the server. The main things that we need to take care of right now is the router, and that's about it. So the backend router uses groups to allow for robust endpoint functionality. So in our setup router function, we initialize different routes. But before we do that, we group. Now what this does is any endpoint that gets hit, let's take auth group. Let's take this post, or we would need the front end to hit /API/auth/decode JWT. Now, why is that? Well, this is because this right here is one group, which is the API, and we pass this to all routes. So this has to start first. Then inside of this, we have a nested group /auth. So it has to go after the API if we want to hit any of these. Now, if we want to hit decode JWT, API has to be prior, auth has to be after that, and decode JWT has to be last in order to hit these endpoints. Now, this makes it really simple and manageable when you have huge amounts of endpoints. It makes it really easy to handle, and there's even more abstraction that we can add on top of this. But this is a simple enough. Endpoints use middleware to authorize and authenticate. Here I have a post and a get that call GitHub auth middleware in one of our handlers. What this does is that before the request gets sent to our controller level, it goes through our middleware, our GitHub auth middleware, which, as you may have guessed, authenticates the user using the GitHub ID. And now we have officially finished with number 2. We've gone through views and hooks, state and endpoints. Next up is controllers and services. So at this point, we're going through the endpoint and we're hitting controllers. Endpoints use controllers to handle all business logic. So we have 2 posts here on the left side, decode JWT and /login. As you can see, we're using auth handler, which would be our controller, and we're calling the controller's functions decode JWT and login. The controller shouldn't have much logic inside of it at all. It should really only dedicate itself to the request and the response. So in this example, we only get the response of the service function or the user if it was successful. A second example here, I have a post and 2 gets. We call log activity, get activity totals, and get activity dates. Here, little to no actual business logic. We're just returning a response if there's an error, returning it if it's a successful. Now, controllers use services to carry out all requests to the database and functionality. And in a perfect world, services would carry and handle all business logic, no matter what it is. The controller layer would be a puppeteer to the services. So here I have a get activity totals, which is a controller function. And we call h.service.getActivityTotals. So we call the activity handler service and we call the function inside of the service. This is really, really nice because then we can, inside of this function, get activity totals, which is here, we can handle all the logic. This layer right here is really, really useful because if I were to need to manipulate the data or do some crazy business here, I could have it here. Or I can modify this to be more logic heavy on the repository side. But I count this more or less the same as the service layer. I could have easily added this information instead of abstracting it. I could have this get activity totals functionality inside directly into here. And now you're officially done with number 3. We've gone through views and hooks, state and endpoints, and controllers and service. That is the full stack application. So it takes a lot, but that is the full breakdown of the application and the application lifecycle that I really, really like, and it's been very useful for me. So hope you have learned a little bit more about the full stack application process. If you want to learn more and want to help or want to get a full stack application up and running, I currently have a limited time offer. If I can find it here, I'm helping the next 30 aspiring software engineers in the USA create their first scalable full stack project in just 5 days, completely free for a limited time only. So if that sounds interesting, it's more of what we currently do here, but here I would break down one-on-one how to actually code this up and give you more in-depth examples. So thank you for watching. Peace.